Hello, this is Gary Meyer from Lindau Community College. This screen capture is from my CS 150 Summer 17 online class. Now, what I want to do in this screencast is to talk about Assignment 3. Assignment 3 was the hardest of the first three assignments. It also could be part of the midterm, and so I thought it might be good to review that. I know that some of you had a problem with it, and I also know that some of you have asked to give me new copies with some changes. Now, this is the complete solution, both from the pseudocode and also from the Visio standpoint or the flowchart standpoint. Do not give me this back. If you're going to use this to help get you through your assignment, create your own identifier names, your own constant names, put everything the way that you think you should do it, but do not copy this. I don't want to have it coming back to me as your assignment. Okay? Let's start with the pseudocode. The first four lines are just program comments. Program comments are put there by the person who's putting the logic to leave little information for the person who's looking at it next or for them later on. So basically I've identified the name of the program, my name, the class, a note that please don't use this for your assignment, okay? And that's the end of the comment section. Now the comment character I'm using is from Python, but I very easily could use a double slash from the C family of programs, or anything that's I've identified up front would be a program comment or not part of my logic but just documentation. There's my first keyword start, which signals the start of my pseudocode. I then, in my next section of pseudocode, have identified the declarations of all the identifiers in my program. The ones that have lowercase are variables. Variables change as the program changes. I also put some identifier names that are uppercase. This is to indicate these will be constants. The standard with most programming languages is to identify constants with uppercase, so that the person who's looking at this logic gets a little bit of a key or a little bit of a hint as to what's going to be held in that particular location in memory. Constants never change, so Q cost will only be 2 from the very start of the program to the very end, whereas the variables could change. In fact, you'll see all the variables have been initialized to 0, which means they're empty, and I've all identified all these variables as numbers. You're going to see as we get into the course, you're going to have text or string variables. You're also going to have object variables, so that the variables or identifiers will change. I put a little documentation next to each one of these to indicate what it is. Again, for my purpose, when I look at it again later on, and for you guys, since it's the first time you saw my program, this will give you a little helpful information as to how it's been organized. The declarations is usually the first part of the program after that header comment. Since most logic is designed around inputs that are processed into outputs, that's the way I put this program together also. Here's a comment line for inputs. Here are my 3 inputs where I'm storing quantity, shipping, and also the region cost into quantity, weight, and region. Now, many of you tried to sneak an if statement in here on this region cost. Not necessary. I mean, it'll be necessary in the next assignment, but for now, all I expected the user to do is to put a 3 if it's the West Coast and a 5 if it's any other region. No logic to determine, which one it is based on what region code they put in there, north, south, east, west. This is the input. Once I have the input, I can then do the processing. I multiply the quantity times the quantity constant, weight times the weight constant, region cost. There's no multiplication, just simply 3 or 5. We just transferred it over from the region variable to region cost to make it consistent. These names always have, all are camel cased. So in other words, they're 2-word variables. The first word is lowercase. The second word has a camel hump where the first character is capitalized. I then do my total cost, which is the total cost of the shipping. And then I display the total cost to the screen, and I end the program. This is a workable solution. It's got some stuff that hasn't been introduced too much. I won't talk too much about constants, but we have talked about variables and identifiers, and we have talked about data typing. These again are all numbers. If it's a text or string, that would mean I'm no longer working with number. I'm looking with text, and of course you can't do math with text. There's some other restrictions too. All right, that's that. Now, let's look at Visio next. Okay, this is my Visio drawing. Let me center it a little better here for you guys. And basically what I did my basic flowchart. There's my start button, and there's my declaration section. You may notice that the declaration section is the same as the pseudocode. Typically it is. It's very similar. Maybe not as detailed, but you know what? I've typed it once. Why not throw it in there? Maybe the comments are a little bit over the top. I wouldn't put in there, but I've typed it out, so I'm going to use it. There's all my inputs with a parallelogram. Declaration is just assignment, so that's a rectangle. The calculations are rectangle. The output is a parallelogram, and there's my end capsule that matches my start capsule. Now that would be the the flow chart for this assignment. Okay. Now, lastly, some of you have wanted to play around with Python. The nice thing about Python is not only can I type this all out in in pseudocode format, but I can test it now because I'm using some syntax rules and some structure that's in Python, which is very similar to pseudocode. So, for example, Python, and this is the Thony interpreter, which I've given you guys links to in the class. The gray stuff here is because it's comments. There's my quantity, region, weight. Notice how number has disappeared. Well, number isn't valid in Python. Python simply knows what's the first value. If it's a 0, well, it must be a number then. If it's quotes, then it must be text. So there's some numbers, my constants, some more numbers. There's my inputs. Now the inputs have changed. I'm using a keyword in Python called input. I'm also using a keyword in Python called int. What happens with input? It'll take whatever the keyboard picks up and store it in what's called a string. Well, string's not a number. You can't do math with a string. So I convert the string value of that using the int or integer function to be a number. So this is going to take whatever quantity is put in there. It's going to store it as a number into the variable quantity, weight into weight, and then finally the region is going to be 3 or 5. Now, if I had a fractional piece of, I guess weight, then I would probably make it a floating point number instead of an integer, but I'm just using whole integers for this example. Here's my calculations. The calculations are identical as to what I had in Python. So you can, pseudocode. So you can see Python and pseudocode are very similar. And then lastly, I use a print statement to put a blank line. I put a print statement to display my cost, total cost, and I also put print statements to show quantity, weight, and region. If I want to run this, I'm going to run the little VCR button up here. Okay, I might want to move this up some. This is a Python IDE, which lets me code the program and also test it. So I'm going to put 2 for the quantity, 2 for the weight, and 3 for the region. And the answer is 8.5, and I think that checks. So here's the progression. We started with pseudocode. We modeled it. We then put the model in flowcharts to make it more visual. And then finally we decided that the model looked good enough, we wanted to take the conceptual design and implement it into a code design. And this will let me actually test my code. Now, some of you express some concern you don't quite understand Python. Well, then don't worry about it. There's very little Python in this class. The only reason we do use it is because I want to draw the connection between a logic model and the actual program. Now, hopefully this helps you. It'll help you prepare for the midterm, which is starting this Saturday. I just put an announcement out there for you this afternoon. If you have any questions, let me know. Thank you.